Okay, at this point you know how to use inheritance in C#. When you have a base and a derived class, there are situations where you need to convert an object to a base or a derived class reference. And that's what we're going to learn in this lecture. So I'm going to talk about conversion from a derived class to a base class, which is referred to as upcasting. And then I'm going to talk about the opposite. So from a base class to a derived class, which is referred to as downcasting. And finally, I will explain the as and is keywords. So let's assume we have a class called shape and a class called circle that derives from the shape. To keep things simple, I have excluded the members of these classes in this example. Okay, now let's talk about upcasting. In this example, we have an object called circle, which is of type circle. As you see from this example, in C#, we can convert an object like circle to its base class reference, in this case, shape. No conversion is required, so it's implicit. And now let's look at downcasting. So following from our last example, we can convert shape to a circle object using an explicit cast, as you see in the example. Now, one thing you need to be cautious about is that casting can throw an invalid cast exception. In this example, our shape object is actually pointing to a circle object at runtime. So we can cast it to a circle. But if we try to cast it to another type, like a car, it's going to throw an exception. So here's an example. We cannot cast shape to a car, and that throws an invalid cast exception. Now, to prevent this from happening, we can use the as keyword. So imagine we have an object and we would like to convert it to a car. With explicit cast, as you see here, we may get an exception. A safer way is to use the as keyword. So when we use the as keyword, if the object cannot be converted to the target type, we are not going to get an exception. Instead, what is returned will be null. So in the next line, we can check if the result is not null, and then we can do whatever we want with that object. We also have is keyword. With the is keyword, we can check the type of an object. So we can say if object is a car, then we can safely cast it to the car. Otherwise, we won't do any casting. Okay, let's jump into code and see all these concepts in action, plus some real-world examples of where you need to do conversion between objects. Okay, we're going to see a few interesting and useful things in this video. Let's start by creating a class called shape. So, public class shape. The intention here is to model an application like PowerPoint or Keynote on Mac. So we have the concept of shape, which is going to be common across other concepts such as text, table, image, whatever. So each shape in our PowerPoint application is going to have at least a width and height. So we created two properties, width and height. And at least it needs a position. So we can have an X and Y. We also need a method to draw a shape. So public void draw. To keep things simple, I'm just going to leave out the implementation for now. So let's move our shape class to a different file, just like we've done in other exercises. Alt and enter, enter. Back with Control and minus. Now let's create a class called text that derives from shape. Now our text class needs some additional properties like font name or font size. So font size and font name. Again, we're going to move this class to a separate file. So back to our program. Now let's create an object of type text. Text equals new text. Now I want to show you upcasting. So we can declare a variable of type shape and simply assign it to text. As you see, no conversion is required. So we can implicitly convert an object reference like text to its base class reference like shape. And this is very powerful. I'm going to show you how we're going to use that in real-world applications. But before we get there, let me tell you a little bit more about what is happening behind the scene. Both these text and shape objects are actually pointing to the same object in memory. Well, it's more accurate to say text and shape are both references to the same object in memory, but they have different views. What it means is, if I go here and say text dot, I can see all the properties of a text object. So font name, font size, plus the ones inherited from the base class. But if we use the shape reference, we see a more limited view. So as you see, font name and font size are not there, even though at runtime, the object that we have in memory does have those properties, but we are not going to see them if we use the shape reference. Now you might wonder, why do we need a more limited view of an object? We'll get there. I'll explain that in a real-world scenario. But for now, let's just do a simple experiment. So what I'm going to do is, first I use the text object and set the width to 200. Now I use the shape reference and modify that width to 100. Finally, I'm going to display the width of the text on the console. So console.writeLine, text.width. What value do you think we're going to get on the console? 100. Because both text and shape are references to the same object. They just have different views. Let's run the application and verify this. There you go. So we got 100. Now, what's the point of converting an object reference to its base class reference? Well, this is actually very powerful. And that brings us to a new topic called polymorphism, which we're going to see in the next section. But for this video, let me give you some insight about where we're going to use this kind of conversion in a real-world scenario. Well, first of all, let me clean up all this code here. Okay, in .NET Framework, we have a class called StreamReader, which we use to read data from any stream of any kind. So let's create an object of type StreamReader. So StreamReader, reader equals new StreamReader. Okay, note that here we have a few overloads for the constructor of this class. The simplest one is the one that takes a stream object. In .NET Framework, stream is the base or parent of every kind of a stream. For example, file stream or memory stream. Let's take a look at them in the object browser. So we go to View and then Object Browser. In the search box here, let's type file stream. So here's our file stream class, which is defined in system.io namespace. Here's the declaration of the file stream class. Note that it derives from stream. And here are the members of the file stream. So we use a file stream object to work with a file. It has methods to read from a file or write to a file. Now let's take a look at memory stream. So back here, search for memory stream. Again here in the declaration of memory stream, note that it derives from stream. Now let's get back to our program. In practical terms, in the constructor of StreamReader, we can pass any object whose type derives from the stream class without any conversion. So what we can do here is we can simply pass a new file stream, or we can pass a memory stream, so any class that derives from the stream class. So back to our upcasting concept, the object we send here will automatically be upcast to its parent class, which is stream. Let's take a look at another example. So I'm going to comment this out. We have a class called ArrayList, which we can use to store objects in a list. So ArrayList, list equals new ArrayList. Or we could use var here to keep our code cleaner. Now let's take a look at the add method. The add method takes an argument of type object. And remember, object is the parent of all classes in the .NET framework. So essentially, what we can do here is we can pass any object to this add method. And no conversion is required. So I can add a number here, or I can add a string, or I can add a text object, and all of these objects will be implicitly converted to the base object class. Now, in real-world applications, we should not really use the ArrayList class because it's not a type-safe kind of list. As you see, we can store a different kind of object in every element. So in this example, the first element is a number, the second one is a string, and the third one is a text object. So at runtime, we may get exceptions as a result of converting array elements to target types. A better way is to use generic lists. So we can use a generic list class like var, let's call it another list, equals new list. This is a generic class. A generic class takes a parameter which is used to enforce some kind of constraint on that class. So for example, if I put integer here, my list is going to be a list of integers. So every element in the list is going to be an integer. Or we could use a list of shapes, which means every element is going to be of type shape. So we can store a shape object or an instance of any of its derived classes. Okay, so that's all about upcasting. Now let's take a look at downcasting. So let's clean up all the code here. I'm going to declare a shape object. So shape. And now I can assign it to a text. So even though at compile time, the type of our shape object here is shape, at runtime, its type will be text. Let me show you what I mean by that. So I put a breakpoint here using F9. I run the application in the debug mode using F5. Now we press F10. Okay, here in the watch window, let's clean up whatever we had here. So I just type shape. So this is a way to watch objects and their content in C#. So as you see, our shape object is actually of type text, even though I declared it as shape. Now the problem with this shape object is, if we type shape dot, we get a limited view, as I explained earlier. So we are not going to be able to access the properties defined in the text object. So that's where we need to downcast the shape object. So what I would do is I declare a text, call it text, and I apply a cast here. So I want to convert shape to a text. Now, with this object, we have access to every property in the text class, like font name or font size. Now you might wonder, what is a real-world example of having to downcast objects? Well, to demonstrate that, I'm going to close this project and create a new project. I'm going to use WPF application, or you could use Windows Form application. Either of these are used to build desktop applications for Windows. So let's go ahead with WPF application. I leave the defaults in terms of name or location. It doesn't really matter. Okay. Okay, here's our designer. And as you see, we have a blank form. So if you run this application, we're just going to see a blank form. There you go. So just a blank form. Let me close that. Now what I want to do is to put a button on this form. So from the toolbox, find under Common WPF Controls, drag and drop button here. Now double click that. The designer creates a method here called button_click. This method will be executed when the user clicks on the button. We can just display a message here, messagebox.show hello world. Let's run the application. So I click the button and we got this hello world message, right? Okay, now let's take a look at the parameters of this method. The first one is of type object, and it's the sender or source of that click event. In this case, that's going to be a button. But the problem is, if I type sender dot, I don't see any properties or methods related to the button class. All I see are the members defined in the object class. This is a very common case where you need to downcast an object. So we can do a cast to a button and store that in a separate variable like button. And here we have access to all these properties and methods of the button class. There you go. Now note that in this example, because I was sure that this method is the click handler for a button, it's safe to cast it to a button like this. But if there are situations where you're downcasting an object and you're not sure about the runtime type of an object, that's where you use the as keyword. So alternatively, we could do sender as button. And then if button is not null, here we could have any code that requires to access a button object. So at this point, I know the conversion was successful and I can type button dot actual height. Let's put it in a message box. And we need to convert that to a string because actual height is a number and the show method of the message box requires a string. So let's run this application. I click the button. Note that we got 21.96. Okay. And now we got the second message box, which is the hello world. Okay, well, that's pretty much it for this lecture. What I want you to take away is, in C#, upcasting is implicit. So you can simply convert an object reference to a space class reference. In practical terms, that means wherever a method requires an object of a given type, you can pass an object of that type or any types that derives from that type. The second thing I want you to take away from this lecture is, in situations like handling the click of a button or anywhere where in your method you get an argument, and that argument gives you a limited view to that object, you can use downcasting to convert that object to a more specific type. And to do that, you can use an explicit cast or the as keyword. I hope you enjoyed this lecture and thank you for watching.